So let's say this question 21. Merge two sorted list. You are given two linked list 1 and list 2 in the input, and then we are required to return the head of the merged linked list. And then we should make sure that the merged linked list should have the same order as the order is maintained in the both lists. So if there is 1, 2, 4, 1, 3, 4 here, then after merging it, it will return 1, 1, 2, 3, 4, 4. So that means we are trying to merge these two lists in such a way that ascending order is maintained and no list is lost. Okay, so let's see. Actually, we have 1, 2, then 4. In second list, we have 1, 3, 4. We're required to merge these two lists. Okay, there are two solutions to this problem. There might be iterative solution and the recursive solution. But you know what? If you see Leetcode, so if you see the test case range, it is very less. It is from 0 to 15. So either of the solution will work in a time frame. But here I think the cost is about memory. Okay. So if you are going with recursive solution, then actually surprisingly the iterative solution will take less memory than the recursive one. Why? Because in the iterative solution we are creating a dummy node actually for keeping the reference of first node, and then in this case the creation of one new object takes much more memory than the than the algorithm which is working behind recursive solution. So but still we will do with we will start with iterative solution. This is because since the input is less, so here recursive will also work. But what if you increase this 50 to maybe 1000 or 4000? Then in that case recursive solution will not work, it will show stack overflow. So let's continue with uh, the iterative solution, but in the next video we will see the recursive solution. Okay, so what we are going to do here is actually suppose we are what we are going to do is we are going to create a dummy node. Okay, and then suppose that we have created a dummy node which is having a value 0. Okay, and then we are pointing the for example this is a dummy node, and then we have 1, 2, 4, 1, 3, 4. Okay, so let's create a big one. 1, 2, 4, then here is 1, 3, and then we have 4. Okay, so what is here? Our head is pointing, list 1 head is here, list 2 head is here, and this is dummy node. Okay, let's call it D. And then we are creating a new node due to which slightly memory was wasted. So let's say it is head. Okay, it will point to the first node always because I want it to save here. I want this pointer, head pointer, to remain always at head at 0. That means dummy node, and we will move dummy node. Dummy node is for moving. Okay, it is used for connecting, but head will always point to this node because we want to save it later when we want to return the answer. Okay, so what is the algorithm working behind is it is that we will compare list 1 and list 2. Okay, if list 1 is less than list 2, then we will we will point the next reference of dummy to the smaller one, that means list 1. Else we will point the next reference of dummy node to list 1. Okay, in this case it is not smaller, it is greater, so else block will get executed, and this it will point to the list 2, this. Okay, and then we have this one and then this one. Okay, there is null. Next, last one is referencing to null. Okay, so we have this node here and then this node here. Okay, now you know what, after every connection we are going to move ahead list node here, list 2 will come here, and dummy will come here. List 1 will not move because it is not participating in connecting two nodes. Okay, list 1 will be here because why it is not participating, because it was not small. So next time we will check it. Okay, so Currently my list 2 is here and list and dummy is here, list 1 is here. Now again let us again check. List 1 is less than list 2. Yes, connect. Yes, correct. Then point the next reference of dummy to list 1. And dummy will point to this one. And this link will get wasted. Okay. So what is my linked list here? 0, 1, 1, 2, 4, and then null. And what is the second one? Second one is we have 3, 4, and then x. Since it is not participating, list 2 will remain here, and list 1 was here, but since it is participating in connection, it will move ahead. And then you know what, dummy will also move. Now where will dummy? So actually MS Paint was not working actually. So you know what, list 1 was here, and then after connection list 1 will move ahead. So list 1, it is not list 2, it is list 1 actually. So list 1 will move ahead to list 2, and dummy node will point. Dummy node was pointing to this one, but now after connection dummy node will also move here. Okay, now we will compare this list 1 and list 2. So list 1 is less than list 2, no problem, because the next point of dummy will always point to the node which is smaller. This time it is smaller, so no problem, we will move ahead. List 1 will become this one and dummy will become this one. Now again we will compare list 1 and list 2. So this time list 2 is less than list 1, therefore we will point the next reference of dummy node to list 1, and then this link will get broken. So what is the new node? 0, 1, 1, 2, 3, 4, and then null. And what about the other one? This is 4, and then next. It is not participating, it will not move. And what was the position of list 2? This one. Now list 2 will move ahead. This is list 2. What was the position of dummy? 2, and then it will move ahead. 2, 3 actually. So dummy is here. Okay. Now again we will comparing list 2, 1 and list 2. What is this? This 4. Okay. Now what is happening here? So list 1 is not less than list 2, so else block will get executed and next reference of dummy node will point to list 1. So this one is going to point out here, then it will get wasted like this. So what is the next one? 0, 1, 1, 2, 3, 4, and then now what about other one? 4, and then x. We have here list 2, and then now after the connection, since list 1 is participating in connection step, so it will move ahead. So list 1 is here, and then dummy node was here, but dummy node will be here. So you see this is the most significant step now. Why? Because list 1 is null, and our while loop will run only if both the statement, that means both list 1 and list 2. If both the list 1 and list 2 is not null, then only run the loop. If any loop becomes null, then immediately stop the loop. Now what will happen after stopping the loop? I will make a condition that if suppose L1 is null, then point the next reference of dummy node to L2. Suppose if L2 is null, okay, if L2 is null, then point the next reference of dummy node to L1 and simply return what? What do you want to return? I will return head dot next. Why? Because head is still pointing to the first node, dummy node, okay, which is here H, and dummy node is lost. Dummy node is here and there, so we cannot retrieve our whole linked list with the help of dummy node. We will do it with the help of head. Okay, so just return head dot next. Okay, so it is Java solution. So let us code it first. Okay, let's see what it is. Let's make the screen big. Perfect. Then let's just code it. Okay, so we will make a list node which is dummy. And then we'll say anything, we can set any value, say it is null, and then we kill it again, another node, just node, and just point to dummy. It is used for saving. Okay, so it is used for saving purpose. We will use it later. Okay, we will use while loop if list 1 is not equal to null and list 2 is not equal to null, then what we do if suppose list 1 dot val is value is less than maybe this two, and in that case we're going to just connect dummy dot next with smaller one, that is list one. Okay, and then we will just move ahead. List one is equal to typo. List one is equal to list one dot next. Okay, then in else condition we're going to do dummy dot. Okay, should we give here condition or else will work? No, it will work. Okay, dummy dot next is equal to maybe list 2, and then list 2 is equal to list 2 dot next. And now we will just move the pointer of dummy to point to the next node. Dummy equal to dummy dot. Okay, I think this typo here. No, it was not dummy. Dummy equal to dummy dot next. Okay. Now the edge case. Only edge case is that I will have to explain edge case also. So let's see if suppose list 1 is equal to null. Why? Because the flow of control will come here only if at least one will become null. Why? Because while you will execute if and only if both of them are null. Okay, both of them are not null. Okay, so if list 1 is equal to null, then you know what? Just set dummy dot next equal to what list 2, which is not null. Else just set dummy dot next is equal to list 1. Sorry, list 1. And then I'll just return what head dot next. Let's see what is happening here. If there is any typo or some mistake. Well and good. Let's see about. Let's submit it. So it is time efficient and it is quite space efficient also. Okay. Then let's continue next video with recursive approach.